In this video, I'd like to compare a points-based system with grading to a weights-based system. And this is something that in my own classes, I always get emails at the end of the semester where students say, I added up all of my points that I earned out of the total points that were available. I divided by that total, and I'm not seeing the right grade. The grade that I see is not the grade that I'm calculating. So what's going on? And what's happening there is those students are calculating their grade, assuming that it's a point-based system. Add up all the points, divide by the total, and you get your grade. In that system, each point is weighted the same. So 1 point on a quiz is pretty much the same as 1 point on the homework, 1 point on an exam, and so forth. And so if we consider that type of a system, with the problem that we see here, we have 4 types of assignments: homework, quizzes, tests, and a final exam. And there are 400 total points in this course. This individual earned 86 points from homework, 95 from quizzes, 78 from tests, and 82. In a points-based system, all we have to do is just consider what's the total amount that I earned as an individual and what's the total amount available and what percent is that. So if we find the sum, we add up all the points that this individual earned. The total points that this individual earned was 341. Now there were 400 points available. So 341 points out of the total of 400. We know that that can be turned into a decimal, which we get 0.8525. And as a percent, this is an 85.25%. This is the most common way that students will email me, at least in the courses that I teach, to say, I calculated my grade this way, and that's not the grade I see. And the reason why is because in the courses that I teach and in some of the other applications that we're going to see this week, the grade is calculated, or some other average is calculated, not based on the total, but based on a weight-based. So homework might be weighted less than your final exam. 1 point on the homework is not equivalent to 1 point on the final exam. So let's look at an example that incorporates these weights. Now we want to look at an individual who scored and had an average percent of an 86% on their homework, 95% on their quizzes, 78% on their tests, and a final exam that was worth, 82% on their final exam. And in this scenario, what we know is that 50% of the individual's overall grade, and these weights that we have here, are relative to some overall grade. So 50% of that overall grade at the end of the semester is going to be accounting for or due to their score on the tests. 25% of their overall grade will be as a result of their score on the final exam. And we see 10%, 95% is only going to account for 10% of their overall grade, and their average on their homework of 86% will only account for 15% of their overall grade. So although they did really well on their quizzes, as we see here, they did really well on their quizzes. They got a 95% on all their quizzes as an average. That's only going to account for 10%. They didn't do as well on their tests. On their tests, they got a 78% average. Unfortunately, that's going to count for exactly half of their grade. And so there's 2 different ways that we can approach this, and honestly, they're the same way of calculating this weighted average, but I want to use these words proportion, a kind of a proportion approach versus a formula approach. And what we're about to calculate is a weighted average, and you might also see this referred to as a weighted mean. From a proportion approach, what we want to think about is what percent of the final total amount, or what proportion of that final total amount, is due to some score. And now if we add up all of the weights, and this is going to be, in this problem, not terribly, not challenging, and it's probably going to be expected of what we'll see, but in future problems, the sum of the weights will be different. So if we add up all these weights, we get 100%. So 100% of the total score, or total grade. That is the kind of the sum here of all of these weights. What we know about this individual is that 15% of their overall grade, 15 out of 100, is going to be, pushing forth or almost kind of voting for worth 86%. So 15 out of that total of 100. So 15% times 86%. This is kind of the formula, or excuse me, the proportion approach. We know 10% out of the 100 is going to be made up of 95%. And I'm going to, and maybe it's not best to write the percentages in there. We know that we're going to be talking about percentages. We know 50% out of 100, so 50 out of 100 is going to be worth a score of 78. And finally, 25 out of 100 will have a score of 82. So what we're doing here is using kind of a breakdown based on these weights, 15 out of 100, 10 out of the total 100, 50 out of 100, and that particular weight is associated with these scores. So 15 out of 100 has a score of 86. We know a 95% is only going to be weighted 10 out of 100. 78 was our average for the tests, which needs to account for 50 out of the 100. And 82 needs to account for 25 out of 100. And so now what I want to do is just go ahead and calculate what this is. So I'm going to go ahead and put all of this in my calculator. So I went ahead, calculated all of these values, and I got 12.9, 9.5, 39, and 20.5. Now when I sum all of these, I get 81.9. So the average here, the weighted average based on these weights of 15, 10, 50, and 25% respectively, the weighted average or weighted mean, this individual score is 81.9%. And we can get this by considering the proportion or the part to the total associated with the weight times the score associated with that weight. So we had 15 out of the total of 100 that was associated with a score of 86%. And we add 10 out of 100, and that was associated with a score of 95, and so forth. This is more of, at least in my mind, a proportion approach by just thinking of the fraction or the proportion that is relevant to that particular score. Another approach is to use a little bit of a formula. And if you were to Google or search a weighted average or weighted mean calculation, it's likely what they're going to show you is this type of a formula, where they're going to just take each individual weight, they'll multiply that by the value associated with that weight, and I'm not going to use any mathematical formulas here, but they'll do this, maybe I'll use a weight 1, value 1, they'll do this for every single weight and every single value. So you might have another weight and a value, ... and you'll add all those up, and then you'll divide by the sum of the weights. So we're honestly doing the exact same math. It's just writing it in a little bit of a different way. So I'm going to zoom out a little bit. So for this first approach, for the homework, the weight associated with the homework, it was 15. So 15 times the value of 86%. So I have the weight times the value associated with that weight. Now for the next value, I have 10%, so the weight is 10%, so just 10 times that value associated with that weight of 95, plus we have a weight of 50%, so I'm going to write that as 50 times 78, and then finally 25 times 82. Now we want to be careful. If you are putting all this in your calculator, we have to make sure we are following the order of operations. And then we're going to divide that whole amount by the sum of all the weights, which we know was 100, so 100%. This is another way for us to calculate the weighted average or the weighted mean. So I'm going to go ahead and pause this, see what I get when I plug that numerator into my calculator. So, unsurprisingly, I get 8,190 in the numerator. I divide that by 100, and I get 81.9. I get the same weighted average. So this individual had an 81.9% weighted mean or weighted average. Mathematically, these are identical. All that's happening here is we are, here on the left, taking a proportion approach. So we're thinking about the fraction of the total, so 15 out of the total 100 is being associated with an 86% score. If we were to kind of pull out a 100, a 1 over 100 from all of these, we can just rewrite that as this formula. So again, how you calculate this is completely up to you. You can, and again, they're the same. If you can see the connections between them and why algebraically they're exactly the same, that's fantastic. But how you show your work moving forward is completely up to you. Let's look at another example. Here's another example that if you want to pause the video and try this to calculate what this individual's weighted average or weighted mean, overall score, however you want to call it, if you want to go ahead and calculate that, go ahead and pause the video now. I'm going to go ahead and do this. So we have a couple approaches to do this. One is just to take the weight, multiply by whatever that associated score is, and sum those up, divide by the sum of the weights. So because we're dealing with percentages, it is not a surprise that if I were to add these up, I'm going to get 100%. So the sum of the weights, although in this problem still makes sense, it's 100%, it's going to be a really important part of future calculations that maybe don't involve percentages but have weights being represented in a variety of ways. So we want to find out what is that sum of the weights. Now, if I want to think of it more of a formulaic approach, I can take each of the weights, multiply by the score associated with it. I have no idea why I wrote 24, so let me erase that. The weight of 25, we know that this individual scored a 75% on their homework, and the weight associated with that was 25. They had a perfect 100% on their quizzes. The weight associated with that was 15. So we take the 15, the weight times the value associated with it. Now I have another weight of 35% of this person's overall score, overall grade, is associated with a test score of 86. And finally, 25% of this person's overall grade is determined by the final exam, which was a score of 75. Now, if I divide that by the sum of all of the weights, which of course we know is 100, then what we're going to get is our weighted average. So I'm going to pause here and calculate. So I got 8,260 over 100. And when you divide that, you get 82.6. And we know the unit associated with this is percent. So this is an 82.6%. This is the weighted mean or the weighted average. And we can associate that. This is kind of their overall grade. So this is taking more of a formulaic approach. Again, the calculation is based on the weight and the value associated with that. We can also think about this almost like a fractional or proportional perspective as well. And that is 25 out of 100 is associated with a score of 75%. 15 out of 100 is associated with a score of 100, and so forth. So these percentages out of the total are fractions. And I realize I just drew over there, and it's probably making things complicated, But we can take the weight, 25 out of 100, 25% out of the total of 100 is going to be associated with a score of 75. And we can add to that 15 out of 100 out of the total of 100% is going to be associated with 100, a score of 100%. 35 out of 100 has a score of 86. And finally, 25 out of 100 has a score of 75. And if you were to do all of that multiplication and addition, you're going to get exactly 82.6. So this is associated with an 82.6% overall grade. Mathematically, these are absolutely identical. All we're doing from, the first method that we did to the second method is we're kind of breaking this up into individual sums. So instead of finding the sum of the entire numerator and dividing by 100, we're actually taking 25 out of 100, multiplying it, adding 15 out of 100, multiplying. So it's the same mathematically. Depending on how your brain might approach it, it might make one of these perspectives might make more sense than the other.